Check, 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 check. Okay. Audible, visible. Please wait. Am I audible? Am I visible? Give me a thumbs up, thumbs up, thumbs up. Okay, so let's get started. Hello, check, 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 check. Students, can you see me, hear me? Hello, hello, hello. Please give me a thumbs up. So, energetic students, energyful students, how are you all? So, welcome to the Noodle Chopstick series, and we have spoken earlier as well. The name of the series comes from the fact that when you have to solve a problem, there are multiple ways to do that. And two of the most common ones are one is noodle method, which is more like, I don't know, why would you even use it? And another one is the chopstick method. It's a straight method. You go from point A to point B. There is no confusion, nothing. So there is a noodle method and there's a chopstick method. And obviously the noodle method is very, very confusing. It is very lengthy, it is error prone, and it is difficult to grasp. But still, many teachers use it. And I don't know why, but I came up with two theories on that. The first theory I came up was that maybe those teachers, when they were students, they learned it that way. And they don't know there is a simple way out there. Or maybe they know, but they want to portray this topic as a rocket science, as if you had not come to me to study, you would have never got it. So thank yourself that you got fortunate, lucky enough to get a teacher like me. I don't know, whatever the reason is, and I don't care about it. The point is we are going to stick to the chopstick method. So if you're part of this session, we are going to simplify the things here. So my name is Bhavdeep Sethi. I've been converting physics haters to physics lovers and never, never, never memorize physics. And I always tell the nature is the best textbook out there. So whatever textbook you're going to buy, that obviously it's precious. If you study at C. Verma, yes, nothing about it. But the best textbook above all is the nature. So physics is learned from the nature. So today we'll talk about the temperature scale. So what is a temperature scale? It's basically a tool to quantify the temperatures, right? So let's say I tell you it's very hot in my city today. And you might say, okay, it's very hot in my city as well. But then that is a qualitative kind of, and which one is hotter compared between these two? So we actually have some numbers, right? We always quantify things. Like if I say the market is very far away, you might say, okay, how many kilometers? You want a number out there. And that's what we are doing with the temperature scale. We are putting a temperature now. So I might say, okay, it's 40 degrees in my city. You might say it's 42 degrees Celsius there in your city. So now we know, okay, we have a measurement out there. So your city is hotter. Similarly, if you want to measure the body temperatures, if you see it's 99.5 degrees Fahrenheit, you will say, okay, it's normal. But if it comes out to be 101 degrees Fahrenheit, you might say, okay, I have a fever. So that is what the temperature scale is. You have been using it since your childhood. You use it every day in your life. So what is the confusion about? Confusion is because there are many scales out there. Just now I spoke about Celsius and Fahrenheit. So there are many, many scales out there. And the confusion is how do you convert? Obviously, most of you will say, I know the formula 5 by 9, f minus 32 and all that. But see, the problem with memorizing those formulas is you don't understand in depth. You don't know the reason why that formula exists at the first place, and maybe in the examination hall when there are 3000 formula in your brain, you might forget it's 9 by 5 or 5 by 9. Is it F plus 32 or C minus 30? What is, yeah, I mean, so formula is not the way to learn. You have to learn conceptually and the formula will follow. And that's exactly what we will do. I'm not asking you to solve this, so don't start solving it. This is just as an example. So we have to convert. So how do you convert? Let's make it easy. Let's make a road. I understand that we are not studying traffic here, but we are studying temperature. But trust me, this is going to help you a lot. So let's say we make a road here. So this is a road, right? Now back in days, people used miles. So that's where the term milestone comes into place. So let's say there is a milestone here which says 0 miles. So it says 0 miles, milestone, you know. Now then there is something like the 100 miles, 100 miles. You will really admire the way I'm telling you. It's very easy. Now, obviously, we have moved on to standard notations, so miles are not understood by many. So maybe on the same road, there's another milestone, or let's call it kilometers stone, and this says 0 kilometers. Now, 1 mile is roughly 1.6 kilometers. So what will happen now? This is going to be 160 kilometers. So easy enough. So for now, right? Now, different units of measurements here. But now let's say I start the journey and I complete half of the journey. So when I complete half of my journey, whatever scale I'm using doesn't really matter. I've completed half of my journey. So I would say I have completed half of the journey as per mile scale and kilometer scale. It doesn't matter. So mile scale says, okay, from here to here was 100 miles. So half of the journey is supposed to be 50 miles. Good. When kilometer says, okay, you completed half of the journey, the full journey was 160 kilometers long, so half of the journey has to be 80 kilometers. So far, so easy, right? But now let's change the situation. Let's change the situation and erase all this and say maybe the kilometer marking scale started somewhere earlier. Doesn't have to be here. Maybe zero kilometers was there. So if 0 kilometers was there, maybe by the time you reach here, it is already 100 kilometers. If this is 100 kilometers and we know the whole journey is 100 miles, which is 160 kilometers. So if this was saying 100 kilometers, this has to say 260 kilometers. Now these numbers don't change the fact that you have completed half of the journey. Just by changing these numbers, the fact that you completed half of the journey did not change. So in the perspective of miles, okay, half of the journey is 50 miles. From this perspective, what happened just now? See, it says 260 kilometers, but in reality, your journey was not 260 because you started at 100, you reached 260, your total journey is only 160 kilometers. So the full journey is 160 kilometers. So the half of the journey will be half of it, which is 80 kilometers. So you will say, okay, I started at 100 kilometers, I traveled 80 kilometers, so this one is going to be 180 kilometers. Right, easy out there. Now, similarly, let's say I completed 1/4 of the journey. So I'll say, okay, from the mile perspective, if I completed 1/4 of the journey, that means I have completed 25 miles. From this kilometer thingy, it's 160 kilometers the full journey, 1/4 is 40 kilometers. So you will say, oh, this is 140 kilometers. And these numbers begin and do not matter. What matters here is this divided by the whole is going to be the same. If you understand proportions, ratios, fractions from a 5th or 6th grade, that's what we are talking about. So what we are saying is the journey completed divided by the full journey is same, whatever units of measurement you take. I'll repeat that. So journey covered divided by the full journey is going to be same, whether it is whatever unit of measurement. Now we take this to the temperature scale. So let's talk about temperatures now. Now there are different temperature scales, but very common ones are Celsius and Fahrenheit. So whenever Fahrenheit scale was started, or when the Fahrenheit scale started, They said, okay, we'll take the melting point of ice and boiling point of water, and we take them as standards. So they said, okay, for whatever reason, I mean, there are historical reasons for those, but maybe someday I'll make a video on that. But for now, we'll proceed here. So they said, okay, whenever the ice melts, we will call that as 32 degrees Fahrenheit for whatever reason, right? And they said, okay, start heating, 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 and when the water starts to boil, we'll call that 212 degrees Fahrenheit. Now you can see a similarity here. We started at 100, we reached 260. So we started 32, we reached 212. The journey here is 180 degrees Fahrenheit. Celsius people said, okay, let's keep the thing simple. As in, we'll call this temperature where the ice starts to melt as 0 degrees Celsius. And we'll call the temperature where the water starts to boil as 100 degrees Celsius. So you can see the analogy here. So 0 miles, 100 miles, 100 kilometers, 260 kilometers. Same kind of thing happening here. So now let's say I would like to convert 20 degrees Celsius to Fahrenheit. No formula please. No formula, no ready-made equations. Just pure common sense. Fifth grade, sixth grade mathematics is what we need. So let's say I want to convert 20 degrees Celsius to Fahrenheit. I'm not using any formula. I am saying when I started my journey from here to here, I see I have covered 1/5 of the journey. The full journey was 100 degrees Celsius. I've covered 20 degrees. So that's 1/5. So that should be same in this case. The full journey here is 180 degrees Fahrenheit. 180 degrees Fahrenheit, the 1/5 of that is 30 degrees Fahrenheit. So I would have traveled 36 degrees here. But then I started at 32. If I start at 32, I go 36 more steps. That's going to lead me to 68 degrees Fahrenheit. And that is what it is. It is as simple as this. I completed 1/5 of the journey here. So I should have completed 1/5 of the journey here. Now, taking this as a general case, let's say on this scale, there is some temperature C. And I would like to find the equivalent F of that. So I would say this distance, the journey covered, divided by the full journey has to be same in both the scales. So I will say from Celsius scale, the journey is C minus 0. Why am I saying minus 0? Because that's where I started. It could have been 10. So in order to highlight the fact that C minus 0 has to be done, I will write this as C minus 0. So this is this distance divided by the full distance. Full distance of the journey was 100 minus 0. I'll still write it as minus 0 because what if it was something non-zero there? Now from Fahrenheit perspective, the journey is F minus 32. See, if you're F here, you already started at 32, then your journey is F minus 32. So you completed F minus 32 here. Divide that by the full journey. The full journey is 212 minus 32. Now, if I simplify this, this becomes C by 100. So I'll write C by 100 should be equal to F minus 32. F minus 32. Divide that by 212 minus 32. That becomes 180. Now you can cancel out by 20. You divide this by 20. You get 5. You get 9. And this is the exact formula that you have been memorizing. I mean, there's no harm in memorizing that, but you have to know where is this coming from. Because you might come across some other scale. So let's do some practice. Let's take another scale. What scale? Maybe to make myself happy, I'll make a scale of myself. You can make your own scale. I mean, it's all man-made scales. So to make myself happy, let's say there is a scale and I come up with some idea, some weird idea saying, okay, when the water, or when the ice starts to melt, I'm going to call that 40 degrees Bhavdeep. Why not? I would like to call that 40 degrees Bhavdeep. And then for whatever reason, I say when the water boils, I'll call that as 440 degrees Bhavdeep. Proud feel moment, right? Yeah. Now let's say I want to convert this to Fahrenheit scale. So Fahrenheit scale starts at 32 degrees Fahrenheit and it ends at 212 degrees Fahrenheit. Not ends, but basically from melting of ice to boiling of water. Now let's say I want to do some conversions. Maybe in my scale, I have some temperature, let's say B, some B temperature, some temperature B, and I would like equivalent Fahrenheit on that. So I would say, okay, this part of the journey divided by the full journey has to be same in both the cases. So I'll say F minus 32 divided by the full journey. Full journey is 212 minus 32, that is 180. This should be equal to this V minus 40 divided by this journey. The full journey is 440 minus 40, which is 400. No, I'm not asking you to simplify this. This is the basic idea. I just want to show you. Now, let's say you know the temperature in B. Then you can find the equivalent temperature in F. You just plug in B. Similarly, if you know the temperature in F, you plug in F, you get B. And that's it. I mean, that's it. This is how you should be learning physics. I mean, the basic thing I would like to tell here is that if you're trying to memorize any equation, any formula, you're not learning physics. You're being a parrot. I'm sorry for using that word, but that's what many people do. I mean, they just memorize the formula. Don't memorize, just try to understand. And now, by the way, did you know, as a fun fact, I mean, there are many other scales out there. Two of the other scales that I studied when I was a student was Rankine. Rankine is something which is like Kelvin. It's an absolute measurement scale. It's not as popular as Kelvin, but it's very similar to that absolute temperature. So 0 Kelvin, 0 Rankine. Similarly, another one which I don't know exactly how to pronounce. It's more like Ramure, something like that. And it's used in some places in Europe. So there are many others. I mean, I don't remember, but I remember at least 5 or 6 other. So back in days, we didn't have Google and all these luxuries. So I was sitting in a library and I came across 5 or 6 of them. 2 of them clicked my mind. Okay. So it wasn't that easy. So if that was helpful, like and subscribe to this video and forward it. By the way, I would also like to remind you that there are 2 courses that we have started recently. One is Full Physics Mastery 2025, that is starting on 1st of July, and then there is a free summer camp starting on Monday. So these are the 2 things. So summer camp is all about calculus. Join this. It is free. I mean, there's no charge to that. So what we are going to do is 4:30 to 5:45 every day, continuously 4 days. That's 5 hours of classes. We are going to study differentiation basics, then how to use it in our daily life. Integration basics and how to use it. See, that's the problem with our education system. They teach you. They say learn this, learn that, learn this, learn that. But then they don't tell you how to use it. So here we are going to see how to use it. It's a free. I mean, the link is down there. Join it. There's no charge for that. Another thing that we have started is Full Physics Mastery course. If you're interested in that, you can join that also. It is a 5-module kind of course where we have 11th ka portion and then 12th grade portion. The complete 11th and 12th physics mastery in 17 or 16 months. So we are going to start. So where is it? So we start on 1st of July. September is when the classes end, but in October and November we will have revision classes for NSEP. So NSEP happens in November. So after the classes end here, we'll have revision classes. The course will go until mid of November. So module 1 has been launched. It will start on July 1st. Classes will be Monday, Wednesday, 4:30 to 5:45 p.m. Test is alternate Sunday. The price of all these modules is 2,500 each module. So 2,500, 2,500, 2,500, 25, 25, 25. But as a promotion price for this week only, it's 1999. And also there is a coupon code. I don't know if it is mentioned in the link here. So BS Pro 1, this always works, and it is 10% discount. If you get any problem, you can contact me. I mean, my Telegram ID is Bhavdeep Singh Sethi. I'll write it properly somewhere so that you can. Then I'll write it here. So Bhavdeep Singh Sethi. You can connect with me. Okay. So that's it from my side. I mean, I always want to show, and there's a good news I would like to reveal, by the way. So this, you already know, group got gold medal last year in International Olympiad Physics. Aditi Avnish got chemistry, but there's a bigger news coming in just now. And also 4 students are participating in in the International Olympiad as we speak, but there is a big news here. Anybody who is live right now, can you guess what that news might be? Priyanshu, Rudransh, Manav, anybody who can guess what the news can be. There's a huge news I want to reveal after this slide. What can that be? Any ideas? Any clues? Anything? Any ideas? Okay, so the bigger news, big news here is that as we speak, our student Arnav Sanyal got all India rank 1 in ISI exam. The exam result was declared an hour back, 1 or 2 hours back, and he got all India rank 1. That's a huge achievement, I would say. So that's all India rank 1. We are talking about India rank. है ना? And then another news is Shaunak, because I don't have the picture here, he got all India rank 4. There are other ranks that are pouring in. We only got contacted by these two students as of now, but then we will be getting more news. I mean, this is a huge achievement. ISI, I mean, come on, yeah. This is a prestigious exam. I mean, it's all India rank 1 and 4. It's huge. So with that, I'll end the session. I will encourage everybody to join the summer camp or one of the long-term batches. But students, please remember, I'm just telling you again, this is going to work only till Sunday night. And this promotion was actually till last week, but we extended on some students that we need some time. So Sunday 16th night, this promotion will end. And on Monday morning, the price will revise to 2,500. And then there is nothing much I can do after that. So if you want to take advantage of this and the coupon code gives you only 1,800, then you register now. Then it will revise. I mean, the coupon will still work. By the way, coupon always works. So with 2,500 also you can use it. Okay. So I'll end the class and encourage you to keep up the high josh. Okay. See you soon in the class.